Engines rely on a series of intricate components working together to convert fuel into power efficiently. One crucial element in this process is the piston, which moves up and down inside the engine cylinder. To ensure that this movement is smooth and that the engine functions properly, pistons are equipped with multiple rings. Most modern internal combustion engines use 3 piston rings, each with a specific function to maintain performance and longevity. But why exactly do engines need 3 piston rings? Let's break down the purpose of each ring and explore why 3 rings are typically necessary for optimal engine performance. The top compression ring. The first ring, located at the very top of the piston, is called the top compression ring. Its main job is to seal the combustion chamber to prevent the fuel and air mixture from escaping during compression and combustion. This seal is critical because any leakage of the fuel mixture can lead to reduced engine efficiency, loss of power, and even engine misfires. When the piston moves upward in the cylinder, the top compression ring creates a tight seal between the piston and the cylinder wall. This ensures that the maximum pressure from the fuel combustion is directed downward to power the engine, rather than escaping past the piston. If this seal is ineffective due to wear or poor design, it can lead to lower compression, less power, and higher fuel consumption. The top compression ring must be made from strong materials such as cast iron or steel, as it experiences extreme pressures and temperatures during operation. It's also designed to be slightly beveled or tapered to ensure better sealing and to reduce friction against the cylinder wall. The second compression ring. The second ring, located just below the top compression ring, is known as the second compression ring. This ring serves a similar function to the top ring, but is primarily focused on maintaining a consistent seal as the piston moves up and down. While the top compression ring does most of the sealing work, the second ring plays a supporting role, ensuring that any minor gaps or imperfections in the top ring's seal don't lead to excessive combustion gas leakage. The second compression ring also helps to scrape away any excess oil that may be present on the cylinder walls, preventing oil from entering the combustion chamber. In some engines, the second compression ring may have a slightly different design or material compared to the top ring, often featuring a taper or a special coating. The oil control ring. The third ring on the piston is the oil control ring, which is positioned at the bottom of the piston, just above the piston skirt. The primary purpose of this ring is to manage the lubrication of the engine. Unlike the compression rings, which are designed to seal the combustion chamber, the oil control ring ensures that there is just the right amount of oil on the cylinder walls. It does this by scraping off excess oil that might have splashed onto the cylinder during the engine's operation. This is crucial for maintaining the lubrication of the cylinder walls and reducing friction between the piston and the cylinder. At the same time, the oil control ring prevents too much oil from entering the combustion chamber, which would otherwise lead to burning oil, excessive exhaust smoke, and potentially fouled spark plugs. The oil control ring typically has a different design than the compression rings, often consisting of a thin, flexible steel ring with small holes or grooves that allow it to effectively control the flow of oil. Why 3 rings and not more or fewer? You might wonder, why 3 rings? Why not more or fewer? The reason for this is the balance between engine performance, fuel efficiency, and cost. 3 rings, 2 compression rings, and 1 oil control ring provide an optimal balance of sealing, oil control, and friction reduction, while also keeping manufacturing costs reasonable. On the other hand, reducing the number of rings would make it harder to maintain proper sealing, leading to issues like reduced compression and higher emissions. While some high-performance or heavy-duty engines might have more rings to handle higher pressures or temperatures, the 3-ring configuration is more than sufficient for most everyday vehicles. Piston ring wear and engine maintenance. Over time, piston rings experience wear and tear due to the harsh conditions they operate under. As the rings wear down, they lose their ability to create a proper seal, which can lead to problems like decreased compression oil consumption, and poor engine performance. Regular maintenance, such as checking the engine's compression and oil consumption, can help identify issues with piston rings before they become major problems. In some cases, worn-out piston rings can be replaced during an engine rebuild. When replacing the rings, it's essential to check the condition of the cylinder walls to ensure that there is no excessive scoring or damage. The role of piston rings in emissions control. Piston rings also play an important role in controlling the emissions of an engine. When the fuel-air mixture is combusted, the resulting gases need to be contained within the combustion chamber to prevent them from leaking into the crankcase. If the piston rings don't seal effectively, combustion gases, especially harmful pollutants like nitrogen oxides, NOx, and carbon monoxide, CO, can escape into the crankcase or enter the oil system. This can lead to higher emissions and a greater environmental impact. By maintaining a tight seal between the piston and the cylinder wall, piston rings help prevent gases from escaping prematurely. The evolution of piston ring designs. Piston ring designs have evolved significantly over the years. In early internal combustion engines, simple cast iron rings were used to seal the combustion chamber. Over time, engine designers have improved the materials and shapes of piston rings to increase their durability, reduce friction, and optimize performance. Today's piston rings are made from high-strength materials such as chrome-plated steel, carbon-based coatings, and nitride alloys. Piston ring failure and its symptoms. Piston rings, like any component in an engine, can wear out or fail over time. When this happens, it can lead to several performance issues. A few common symptoms of piston ring failure include poor engine compression, increased oil consumption, and excessive exhaust smoke. If the piston rings become damaged or worn, they can no longer form an effective seal, which compromises engine performance. Loss of compression due to faulty piston rings is often the result of a worn-out compression ring. This leads to decreased engine power and acceleration. How piston rings affect engine performance and fuel efficiency. Piston rings have a direct impact on engine performance and fuel efficiency. The better the seal they provide, the more effectively the engine can extract power from the fuel-air mixture. When piston rings perform well, the engine operates with maximum compression, which allows the combustion process to be more efficient. On the flip side, if the piston rings are worn, it leads to lower compression, which means the engine has to work harder to produce power, thus burning more fuel. Thanks for watching. If you found this video helpful, don't forget to like, comment, share, and subscribe for more automotive insights. Have any questions or thoughts? Drop them in the comments below, and we'd love to hear from you.